Hi everyone, welcome to the Virtual Machine and Virtual Machine Scale Set module of the Masterclass. And really the goal for this module is to dive into what is a virtual machine, what are some of the surrounding components that help us with virtual machines, then the things that are built on top of virtual machines, which is nearly everything, but specifically the virtual machine scale set construct that gives us the ability to scale based on some variation in workload that's actually coming into our system. Now, I want to start with the idea that from a basic perspective of virtual machines, you think of this as IaaS, infrastructure as a service. This is the building block of many things, and it really is used by so many different services in Azure. I can think about the basic virtual machine. So I have just this idea of, sure, it's this virtual machine, which is a singular certain number of virtual CPUs and memory that I put some operating system into. But then there are other constructs. One of the primary ones is a virtual machine scale set. And we're going to dive into this, but what it basically enables me to do is automatically create virtual machines based on some template, based on maybe a schedule. Maybe, hey, if the average CPU is a certain amount of busy, if there's a certain queue depth. So based on work, it can add and remove them to scale with the amount of workload. And their virtual machine scale sets themselves, well, they're used by other things. One good example is with the Azure Kubernetes service, so a managed Kubernetes offering, you have the concept of node pools. And those node pools are typically built using virtual machine scale sets to create the virtual machines that then actually host the various pods that make up your workloads. So this really is a key building block of pretty much everything. You look at the managed database offerings, often they're using virtual machines under the hood. Very few things aren't using a VM somewhere as part of that overall solution. And it is probably the easiest cloud service to understand because it's just like if you were given a virtual machine on premises. If I get a VM on premises, you're given a certain IP address that you go and connect to. And then within that operating system, you can do everything. For example, you get full access to everything inside that OS instance. You can be the administrator. Now, you may still give other people lower permissions. But when I have a virtual machine in the cloud, when I'm using this infrastructure as a service, you get full access to everything inside what is that virtual machine. And so if you think about the various layers of what that means, so what is a virtual machine? Well, you're getting this certain amount of virtual CPU and memory and access to various resources. So what you're primarily responsible for is that operating system that runs inside it, Windows or Linux. And then you may install certain types of runtimes inside it. And then you're going to have your application, which is going to use certain types of data. Now, outside of all that you're not responsible for, sure, there's still a hypervisor. And yes, this is built on Hyper-V, Microsoft's hypervisor, the same one you see in Windows Server, the same one used by Azure Local with a few tweaks. And under that is all of the physical infrastructure. So yes, there are compute services, there are storage services, and of course there are networking components. You don't see any of that. I connect in and I'm responsible for all of these things inside. So I can install anything I want. I can do anything I want within there. I don't have to worry about any of that stuff. Now, with all of that power, also comes a certain amount of responsibility. Because yes, I'm responsible for everything and I can do anything, but I have to consider all of the other considerations and operational processes that make up managing an operating system instance. So, hey, great, I can do everything within here. Maybe not so great. Okay, well, I'm now responsible for thinking about, well, okay, I know I need to think about patching. I know I need to think about antivirus. I have to think about backing it up. I might have to think about DR and replication. I have to think about, well, the firewall configuration. And remember, often there's a firewall inside the operating system, as well as the various things like network security groups, maybe Azure firewall and other things you're running at the network level. Configuration, what I want it to look like. And there's a number of other things. Now, you're responsible for all of these things. Doesn't mean you're on your own. As we're going to look at later on, there are services, there are extensions that can help you with all of these things. But just understand at a very basic level, you own the responsibility to make sure you have something in place to make sure you are patching it, to make sure you are making sure it's following best practices and various other aspects. Now, what we have are virtual machine different series and then sizes within a certain series. Because different workloads have different types of resource need. Some things need lots of memory. For example, if it's a database, it might want a lot of memory. Some things are very CPU demanding. Some things want really good throughput to remote storage. Some things just need huge amounts of network bandwidth. Some want specialized hardware. So we have different needs. And if I think about, well, we have different needs for our requirements, what this means is I might think of different, for example, t-shirt sizes. There's small, medium, large, extra large, and then maybe you have loose fit, athletic fit, moisture wicking for sports. You have specialized different types of shirt and then sizes within those particular types. Virtual machines are exactly the same. There's different series of virtual machines and then different sizes within them based on the particular features I need. Now, the processors they use are Intel, AMD, and ARM. So ARM is the newer type of processors that typically have had a reduced instruction set, but they give you a better price performance. And for a number of the different SKUs, you'll have a choice. For example, the D series, you'll see the D series often uses Intel, but then there's a DA, which uses AMD, then there's a DP, which uses the ARM processor. So you actually can have choices in what makes the most sense for you, what is your type of workload, where one may fit better than another. Now, we don't get to pick specific, well, I want 3 virtual CPUs and 2.5 gigabytes of memory. You are presented with various series and sizes within them. That's really a key point. So the different series of virtual machines, let's go and take a look at these. They have different focus areas. Now, there are a lot of them. And we can see here, it talks about different sizes that are available. There's a different name structure. So you can see here, well, there's a family, there's a subfamily, there are features. Things like the little d means it has local temporary storage. Oh, it supports premium storage. Oh, there's different versions because over time, the hardware advances. And so a V5 would be running a different CPU architecture than a V4 or a V3, etc. And what we can see on this left-hand side is it breaks it down. So there are general purpose type SKUs that have a fairly even balance of CPU to memory ratios. There are ones that are more compute optimized. There are ones that are more memory optimized. There are ones that are focused on storage. There are ones that have GPUs, ones that have FPGA, high performance compute SKUs that then go and work with the various types of orchestrator to submit those high performance jobs. So there's huge numbers of different types. If I look at the D, for example, well, here we can see, well, there's different versions. There's the V6. There would be a V5. You can see V4. Obviously, they retire out the older ones than those. And if we were to just look at one of these basic ones, now this doesn't have the little d variant. So that means it doesn't have local temporary storage. So we see local storage is none. If I was to pick the little d variant of it, well, then we can see it does have local storage. And then we can go and see what are the sizes within it. And what we're getting here is a ratio of 1 to 4. For every 1 virtual CPU, you get 4 gigabytes of memory. And so I would pick the family based on the overall capabilities and then pick a size based on the amount of resource I need. Notice also it's telling you what features are supported. Premium storage, well, that's supported. It's supported because this is the S variant. And then it talks about other capabilities. We're going to get into what generations are, but it supports Gen 2 only, not Gen 1. It has live migration not supported, but it does have memory preserving updates. It has accelerated networking, so it can offload the networking components off to the FPGA in the host. It does not support an ephemeral OS disk, where it doesn't have to have a managed disk for its OS, but I can do nested virtualization. So I could run a hypervisor within this virtual machine and have nested virtualization. And then it goes through the basics. It goes through its local storage, remote storage capabilities. And you'll see as the size gets bigger, you also get more storage performance. I get more network performance. I can have more NICs, which makes sense when you consider what's actually happening here. This virtual machine you're buying, well, it's running on a certain host. That host has an underlying set of capacity in terms of CPUs and memory and network connectivity, local storage, storage connectivity. So the bigger my virtual machine, the bigger the portion of all of the resources of the host I can take. So as I have more virtual CPUs and more memory, well, I can use more of that host local storage. I can use more of its network throughput, more of its storage throughput. And the reason there are different families, for example, the ratios change. That was the D series, but if I go and look at the E series, which is memory optimized, remember this was a 1:4 ratio. If I go and look at a memory optimized, the ratio is now 1:8. So the physical host that these virtual machines run on, they have different structures to handle, well, the different ratios. So there'll be physical hosts that have way more memory than CPUs. There'll be physical hosts that have specialized hardware in them, like GPUs. There'll be certain hosts that have InfiniBand for when I want high-performance compute capabilities. And so you're going to have these different series available for you, which give you the capabilities you need for your workload, because then, hey, it's going to run on certain hosts that can match and provide those capabilities. So when I think about the workload I have, the virtual machine you create really is based around dimensions. So I know I'm going to run a certain type of workload. And maybe it's a domain controller, so it's more of a general purpose SKU. Maybe it's a database, so I need more memory, or I need maybe more remote storage capabilities. So you'll look at, well, what are my CPU requirements? What are my memory requirements? And then what are the other types of capability I need? We just say I/O, but that could be network throughput. There's also storage throughput. You have all these different dimensions. And based on those, and very simplistically, I might think of, for example, virtual CPU to memory ratios. Well, that would help me pick what is the series I want. So as we saw, well, there's actually a little version of the DL. So maybe I would say, okay, well, the DL for little memory, that has a ratio of 1:2. And then the regular D has a ratio of 1:4. The E, well, that has a ratio of 1:8, etc., etc. And so I could then work out what other capabilities do I need? Do I need higher remote storage? Do I maybe need burstable CPU? Do I need whatever that may be? It can help me pick the correct series. So yeah, we have little memory. We have general purpose. We have memory optimized. We have ones with GPUs. You can kind of see and go through all those different capabilities. And the reason there are versions of these is because the hardware is advancing. Microsoft doesn't just buy servers from 20 years ago. Intel, AMD, they're all making new processors. NVIDIA are making new GPUs. There's new versions of InfiniBand, networking hardware. The list goes on and on. And so as you get those new versions, it's because they're running newer hardware underneath. And we can see it. So if I look at the V6, it does tell me. So it will go through and tell me, well, the V6 is running on the 5th gen Intel Xeon Platinum processor. So I think that's the Emerald Rapids processor. If I was to go and look at the E5, so that's the Sapphire Rapids, or the Ice Lake. So it's running on an older version. If I was to look at the V4, it's Cascade Lake or Ice Lake. So there's a little bit of an overlap there. But you can see I'm getting newer versions of the processor as these versions increase. And so there's multiple aspects to what that means for me. It's, well, okay, there's probably new instruction types as part of the newer version, so I'd want to take advantage of that. But also there'll be a general just boost in performance. Now, how much of a benefit in performance I get completely depends on my type of workload. But there's going to be those enhancements. So generally, we want to be moving and keeping up as those versions advance. I don't want to be stuck on a DV2 if the DV6 is available, for example. Because typically I'm paying the same amount of money, but I'm getting a way, way worse performance. The other thing often you see is gigabyte, GIB. That's the true 2 to the power of something, gigabyte 2 to the 30, compared to regular megabytes, which the old gigabytes isn't. It's more about 1,000 to the power of something. So it's that whole 1,024 compared to 1,000 to the power of. It doesn't make a huge difference to you, but they're trying to be more precise. So that's why you keep seeing the gigabyte and megabyte things. It's because it's actually 1,024 to the power of something compared to when you say a gigabyte, it's 1,000 to the power of something. So if that ever confuses you what they're going on about, it's just because they're trying to be very, very precise and they're actually using 1,024 to the power of something. There's also specialized types of SKU you'll see. So if we go back over to here, for example, we look at the D series again, but I think it's in E as well. You'll often see, let's actually see. I know there's a D version. DC, there we go. So these are confidentiality SKUs. And these again can vary based on Intel SKUs or AMD SKUs. So the DC without the A, well, that's built on the Intel, and that has the Intel SGX, so software guard extensions, where you have this secured area of the processor where data is always encrypted. But with the Intel SGX and this secure enclave, I have to write my application to use that secure enclave. So there's work I have to do to specifically be able to use the software guard extension that's part of that confidential compute. Now that's different if I look at the AMD version of the confidential compute. So if we just look at the DCA, so this is using the AMD EPYC processors. These provide a hardware isolated VM that encrypts the entire virtual machine. So they're using the secure encrypted virtualization, secure nested paging, and that's going to give me a whole VM encryption. So I don't have to do anything special to use that encryption. It's just encrypting the whole VM. So there are some benefits when you consider that, oh, I don't want to change my app, but I would like that encryption in use capability. Well, I get that with the AMD SKU, whereas with the Intel SKU, I modify my app, but then only certain processes run inside that software guard extension, which makes me give me a better isolation from regular processes running in the host. So I have choices when I'm leveraging those components. When we talk about these virtual CPUs, hyperthreading is enabled on some of the types of SKUs, and it will tell you if it's using hyperthreading or not. And this is where each core becomes two logical, two virtual cores. Now, it does not double the performance. It varies again on what you're doing. You might see a 30% performance improvement because what normally happens is I have this pipeline of instructions that want to run for a certain thread. And maybe there's a stall. Maybe there's a cache miss. Maybe there's some other reason for the stall. So what hyperthreading does is it duplicates certain portions of the processor so that, hey, if there is that execution state stall, it can carry on and do something with another thread. So I'm not waiting and wasting execution resources. So that's one of the capabilities you get with the hyperthreading. So those are the basics around the capabilities we have. One thing to understand is Microsoft does not over-provision. What I mean by that is if I'm creating a virtual machine with 4 virtual CPUs, it's not going to ever let more virtual machines be placed on a host. So that if they all try to run at 100% at the same time, they would fail. It doesn't do that. Whereas on premises, you might do that. On premises, I'll say, well, I've got 8 CPUs in my box. I'm going to create 8 virtual machines, all of them with 4 virtual CPUs. And I kind of hope they don't all run at 100% at the same time. If they do, maybe I've got waiting in place, but I don't want to waste CPU resources. So that's a benefit in why we like to use virtualization. But in the cloud, you're paying for a certain amount of resource. You're paying for a certain amount of CPU power, so they do not over-provision it. You're guaranteed to always have that much available. If your machine spikes up, there's not going to be a scenario where it doesn't have that much available. Now, there is one exception to that. If we look at the SKUs for a second, one of the things we will see is the B family. This is the burstable SKU. And what's interesting about the burstable SKU is if we just go and look at one of them, you get these virtual CPUs, a certain number of virtual CPUs. You get a certain amount of memory, just like anything else. However, you are not getting the entire performance. What you're actually getting is a percentage of the performance. So 20% or 30%, 40%. And you can accrue credits. You start off with a certain number of credits. And then if I'm using less CPU than my baseline, I start to accrue credits. And then providing the availability of resource is there, I can burst up and go beyond that 20% or that 30%. So you could absolutely imagine the idea that, okay, there's the amount of credit I have. So this is my baseline. Let's say it's 30%. So if my virtual machine is running and I'm running very, very low CPU usage, what actually happens is I start to bank credit. So I'm starting to build up an amount of credit, of burst bank. And then I get some peak that goes beyond what I'm allowed. I need to run really busy for a period of time. I can, because it will start consuming the credit I've built up until it runs out. And then I'll have to drop down to whatever my baseline is. So it gives me the ability to say, hey, normally I don't actually use that much CPU, but I may get busy occasionally. So the burstable is really nice for that scenario. Now that's the VM I'm using. So if I was to go and look over here, so I've got my demo VM. I'm using a B series. And what I have, if we go and look at this, I'm wasting CPU at the moment. So you can see my CPU is actually at 100%. So I'm operating way higher than I should be doing. I'm going to stop wasting my CPU. Actually close this down. So my CPU use should start to drop. So you can see my CPU is dropping nicely. Fantastic. Now with that finished, what I can now do is if I go back and look at the virtual machine, one of the nice things we have is metrics. And there are lots of different metrics available, but I can see my CPU credits remaining. And what you could see here is I started the virtual machine, and after it had started up, it started to accrue credit. And then I started my silly waste of CPU, and I started to consume the credit. Likewise, I could add another metric, and I could see CPU credits remaining. I mean, the scale is almost too small to see. Let's just do. There we go. See it a little bit better here. So I had some credit, and you can see it's like dropping down as I'm bursting and using that up. So that's what the B series lets us do. It lets us have a portion of the CPU of the processor, but then I have the ability to actually, hey, if I've accrued some credit like my cell phone plan, if I don't use it all, I can start to accrue some minutes I can carry over and use and talk a lot more another day. Now, it's not guaranteed. So this is where it is over-provisioned a certain amount. Typically, you're never going to have a problem with this, but just realize this ability to burst is not guaranteed. If you were very unlucky, hey, absolutely, other people could kind of burst and do things at the same time, and then you'll be out of luck. There are other specialized SKUs. So if we jump back over, there are CPU-constrained SKUs. That's maybe a little bit weird. It's like, well, what's the point in that? So we have this idea of constrained virtual CPU sizes. And realize, remember, there's a ratio. And there's this idea that Microsoft have these physical boxes, and there's a certain amount of CPU and a certain amount of memory. But there may be times that I'm running a certain workload. Imagine, for example, I'm over here, and my app is a database server. And I actually need just a massive amount of memory, but it's not actually using that much CPU workload. But there's a limit, even with the memory optimized. If I want, I don't know, 200 gigabytes of memory, I'm still going to end up with a lot of CPUs. Well, that would mean I'd have to pay license fees if it's a per license database server. I don't want to. I don't need the CPU power. I really just want the memory, and I don't want to pay thousands and thousands of dollars for a database license I don't need. And so what you can do is there's certain SKUs that will hide a portion of the CPUs from the operating system. You're still paying for them, but it's going to hide it so I can get other attributes of the virtual machine that it's just a side effect of you have to have a certain number of CPUs that you're paying for. I still get the IOPS, I still get the memory, but I don't have to now pay for the license for some database or other thing that's running on top of it. So you can see there are ones that are constrained, and it's telling you, hey, this one, although it's 32 processors, it's actually constrained. It's only going to show you 16. Or here, it's only going to show you 8. You still get all of the other dimensions. I still get the full amount of memory, the disks, the IOPS, everything else. But now, instead of having to pay for 32 licenses of my database, I pay for 16. Or I pay for 8. So that's the point of this. And it's going to hide and mask those CPUs off from the virtual machine. It will not be able to use them. Now, if you're wondering about the performance of the actual processors in the virtual machines, they used to have this Azure Compute Unit construct, but they've really moved away from it because it doesn't honestly work very well, because what they did is they used CoreMark in the past. But you'll notice they're basically archiving the page. CoreMark does not work well on newer processors. It doesn't consider the new types of instructions or enhancements. And so because of that, the old Azure Compute Unit and these kind of scores, they're really moving away from talking about Azure Compute Units and performance and all those other things. Instead, the recommendation today would be, look, you can see the processors that virtual machine uses. Try your workload on them. measure how it's performing, and from that you can understand, is this the right processor for me or not? So there's really not a good understanding just by looking at it anymore, because there's such a huge variation in workloads and what instruction sets they use and the capabilities they use. You should just look at the processor that they're leveraging and then try your workload out. In general, there was always a minimum of a 15% base performance boost between the versions, but it's so prone to variation because of the workload. It doesn't make sense to keep focusing on that anymore. There is no CPU pinning, just FYI. The hypervisor will move around your logical procs as needed. That's how Hyper-V works, and it makes sure you get the amount of CPU performance that accompanies your particular virtual machine. And so as we look at this, we can see there's different resource types associated. Some of them have CPU constrained, and that processor performance, the best recommendation today would be go and look at what processor is being used, and then from that, go and perform some tests to make sure it's performing as you would expect. Now, there are generations of virtual machine, and this aligns a lot with Hyper-V. Remember, Hyper-V is the underlying hypervisor. There's now Gen 2 capabilities available for Azure virtual machines. So Generation 1 VMs were based on BIOS. You have a master boot record on the disk, whereas Generation 2 uses a GUID partition table. So Gen 1 had a little NTFS system partition. Gen 2 has its own EFI system partition. And then you get sort of the boot partition and other various things if it's Windows. Gen 2 VMs are UEFI based, as accompanying that EFI system partition. Now, UEFI means I get things like a virtual TPM. A virtual TPM lets me do things like secure boot. I get that attestation from the hardware all the way through the signed kernel, the drivers, to the operating system. So I know there's no bad things have snuck in as part of that. Generation 1 uses IDE for the boot disk and then SCSI for the data disks. I can still do hot add remove. Generation 2 uses SCSI for all of the disks. That means I can have a greater than 2 terabyte boot disk. Basically today, you ideally want to be using the Gen 2. You can convert various types of underlying disks, for example, VHDX and VHD. It is not easy to convert a Gen 1 to a Gen 2. If you think about the structure of what you have, there are images specific to Gen 1 and images specific to Gen 2 because of that different underlying boot structure. So that really makes it complicated. One of the things you can potentially do, so VHDX is not supported, but you can convert VHDX to VHD for the disk structure. But what you could potentially do is you could take your Gen 1 virtual machine, you could export out bits of the disk, you could create a new Gen 2 and then try and bring in the OS components, but it's involved. This is not a simple thing to convert from Gen 1 to Gen 2. It's just not. Ideally, you have the ability to redeploy your workload and you would just want to create a Gen 2 virtual machine. And so as I look at, hey, my virtual machine, one of the things we have here is, hey, I got my Gen 1. That is BIOS. My Gen 2 is UEFI. And again, remember the UEFI then brings things like my virtual TPM. Virtual TPM then lets me do things like secure boot, use more advanced functionality. And different images will tell you, hey, we support this generation, or this is for Gen 2. Different VM SKUs may support Gen 2 only or Gen 1 only, and it tells you that information. If we jump back over again and just pick any of them, it tells you. Okay, Gen 2 is supported, Gen 1 is not supported. And it will tell you that if you try and pick an image that's not going to work, it's going to tell you, hey, this image is not compatible with this particular feature set you have chosen. Okay. So there's this huge number of different SKUs available. Is there a little bit of help maybe with which one? Now, there used to be a VM selector, like a help me choose a size thing. But what you now have in the Azure portal is Azure Copilot. And that's now the right thing to help you with, well, what SKU do I actually want? So if we're in the Azure portal, you'll see this little Copilot up at the top. And if I just go to Copilot, now right now I'm looking at a virtual machine. And so right now it's helping me with stuff related to, okay, my VM. But if I come out of this, and now I'm just looking at regular virtual machines, one of the things I could do if I do like my create Azure virtual machine, notice it's actually giving me some Copilot prompts. So help me choose the right VM size for my workload. Help me create a VM optimized for high availability. Help me create a low cost VM. I could also just type it in, but if I just select, well, how do I choose the right VM for my workload? It's now using those large language models behind the scenes to start giving me help to pick. I start off telling it my subscription, and now it can go through and it's going to ask me some questions. And I can just use natural language. So I could say, oh, well, okay, I'm going to be using this for a web server. I don't expect it to be very busy. No, I don't really care about the CPU and RAM. I can basically walk through these things and it will guide me through, well, what is the right type of virtual machine for me? There's even little prompts for other questions and bits of data I could give it. I could say, well, what's recommended for a web server? And then it will go and give me general guidance based on best practices. So this Copilot isn't just there to create virtual machines. This is a really nice capability now for anything you're doing. To say, hey, I need a bit of help with whatever this thing is, and it will actually go and help with whatever I'm doing. So that's really the big thing to help you now when I want to go and create a virtual machine. Use the Copilot. I want to talk about some of the building blocks that actually make up a virtual machine. Now, this is going to be huge because the VM is the cornerstone of so many different things. And so there's so many different options and things that it can be used for. Azure Resource Manager, remember, is the control plane. It brings many services to the various types of things we're doing. But at the base level, we have the virtual machine object itself. And then that base object can have things like, well, is it using Spot? Is it using an SSH key, for example, for its authentication? Now, not every virtual machine is available in every region. And there are tables that go and show up you resources by location. But this is me creating a virtual machine. And straight away, one of the first things, it always has to live in a resource group like everything else. I'm just going to pick one, doesn't matter. And it's going to live in a certain region. There are recommended regions, which are where it gets like those most of the services. Then there are other regions that may have a more of a subset of what's available. So I pick a certain region. Based on the region, there will then be different virtual machine SKUs available to me. Remember from our resiliency talk, I can pick, hey, do I want to deploy it to a specific zone? Do I just let Azure select the zone? I don't really care. Or I don't need AZ alignment. There's no infrastructure redundancy required at all. Or well, I don't want to use AZs, I'm going to put it in a virtual machine scale set. Or I want to use the more old style availability set, so it's on different racks but within the same cluster. So you get to pick that as part of the virtual machine creation. Now, as part of the authentication, if it was Linux, right now this is a Windows image. Now notice in the Windows image, telling me this is Gen 2. Remember we talked about Gen 1 and Gen 2 alignment? This is a Gen 2. But I could just as easily pick an Ubuntu Linux, and there's many other recommended images. If I pick Ubuntu Gen 2, this is where it now gives me the option to use SSH key. So it would actually go and create an SSH key pair for me and create it as an Azure object, which will then make it very easy to go and authenticate to this. So this is where the SSH key type object comes from. But then I use this word spot. Do I want to run it with an Azure Spot discount? Well, that's kind of weird. If I click it, I now get another choice. Is it capacity only or price and capacity? And what is my eviction policy? And what is the size? We get the regular SKU and size we want to use. What is this spot thing? What's the point in this? So realize Azure is a hyperscale cloud. And so they have to have the ability that you as a customer, when I want to go and create a virtual machine, I want to be able to just say, hey, I want to create 10 virtual machines in this region now. You don't give them advance notice. They can go and rack up some additional servers. It doesn't work that way. What that obviously means is if I'm Microsoft, for any given region, I have to have a whole set of capacity. And there's a balance. You don't want too much spare because you're burning money, but I can't have too little spare because then people can't do these scaling operations and create things whenever they want. So if I have a total amount of capacity, there's going to be a certain amount that, oh great, people are paying for, and that varies over time. But that also means I have a certain amount spare. It's just sitting there. It's idle. And we don't like that. As Microsoft, you don't want to just have wasted stuff, but it has to be there so that people can burst up and create stuff whenever they want. So this idle space, they make this available as spot. I'm going to pay less. So I, as a customer, can say, hey, look, this workload is not time sensitive. I can have that workload be stopped, but I'll pay a lot less for it. And I can say, hey, I'll use Spot, but kick me out if someone needs it. Or I'll use Spot and pay up to this amount because the price will change based on how in demand the capacity is. And so I have that choice. And they're letting you pick, well, do you stop it and deallocate it, or do you do something else with that particular virtual machine? So if I was doing rendering, if I was doing batch processing that is not time critical, using Spot will help me save money. That's the whole point behind it. And what we're seeing here in the portal is, hey, look, I just want to use the capacity, but they can kick me out as soon as the excess capacity disappears, or evict me when the capacity disappears, or the cost they're charging for Spot goes up because there's a bit less spare capacity available. And for this virtual machine, do I want them to stop, deallocate it, or actually delete it if I get evicted? So I get various choices. Because remember, I might use this for very ephemeral type workloads that have no state. And maybe I'm just creating and deleting, So just delete the thing if you're going to kick me out. And one of the nice things I can do here is for any particular SKU, I have this ability to view pricing history. So I picked a certain region, and what it's going to do is for the particular SKU I picked, it's going to help me see, based on that particular size, it's not showing me, let's see if there's a different SKU. Oh, that sucks. It's not giving me any price. Normally you can see some price history. But what it is showing me is based on the region I picked, the eviction rate is 0 to 5%. Like, it's very uncommon these are going to get evicted. Then it shows me other SKUs that maybe I would use, other regions. So maybe a different region has a lower eviction rate. So I might go and pick a different region. Here I can see the spot price in WestUS 3 is a lot cheaper. So actually, for my Spot workload, I'll go and create it in WestUS 3 instead and save myself some money. It has the same eviction rate, so I would save myself some money. So if I don't have that time critical, if it's interruptible and can be resumed, using Spot is a really nice option to help me save money. But just realize I can absolutely be kicked out if a regular pay-as-you-go customer wants the capacity and Microsoft's idle is getting reduced, they'll evict me. So you just have to be willing to have that as part of your workload. You have n number of network interface cards. You're going to have one minimum. We talked about this in the networking section, but I can add additional ones. And then based on the SKU, I may be able to have different numbers of network cards. The amount will differ. The amount of throughput will depend. Remember, I have a network configuration inside the guest OS. So yes, in Azure, there's network security groups, there's Azure Firewall, other things. Within the OS, I still have my OS firewall, for example. So I want to be able to consider those things as well. You may have a public IP. You may not. Generally, you don't want a public IP. Ideally, you're sitting behind, if you're offering a service to the internet, you want to be behind a load balancer. If it's to get to the internet, well, I want to use a NAT gateway, or maybe Azure Firewall, maybe a standard load balancer. NAT gateway is specifically geared for providing internet access, but maybe I have a public IP. Maybe I have a network security group linked to my particular NIC. But again, as we talked about in the networking, the better practice would actually be have the NSG on the subnet level. Just from a manageability perspective, it's going to be easier to manage to have it tied to the subnet as opposed to the NIC. Remember, they all get implemented at the same place. It's at the actual virtual switch, the FPGA in the host. I'm using accelerated networking. It's not different places really because there is no real physical network. This is all software-defined networking. I'm going to have an OS disk. Now, this OS disk typically will be a managed disk, but it actually could also be ephemeral. Ephemeral is where it uses the temporary space of that virtual machine, the temp disk space or the caching space, because I don't care about the operating disk. Imagine I have a scenario where I constantly delete and create virtual machines based on some flux in workload. I don't care about the OS disk state. I'm constantly delete and create, delete, create. Well, in that case, rather than pay for the disk, I'll just use that temporary disk space in the host. It saves me money for the managed disk, but it will also be higher performance because I'm not having to go and do those remote storage connections. So if I can, hey, I'm going to use that. And I get to pick what sort of caching I may have on that disk. So this is me creating a virtual machine. But if I come out and actually just look at a virtual machine, and we look at the disks, if I can find the disks, there we go, disks. This is running, so I can't change it right now, but you can pick what the host caching is. Read, write, read, no caching. For database disks, for example, very commonly you won't have any caching configured on them. And notice again, all throughout my experience, there's little bits of guidance to try and help me. It's saying, well, look, your virtual machine supports 23 megabytes per second. The disks attached support 60 megabytes per second, i.e., my VM is not capable of maxing out the performance of the attached storage, which might be absolutely fine. That may be by design. I don't need 60 megabits per second, but it's letting me know as part of my configuration that they're not balanced. My disk is capable of more throughput than my VM can support. If I'm having storage performance issues, well, it may not be the disk, it's I need a different VM SKU or a different VM size that can have a higher throughput so we can take advantage of that connected storage. So that's one of the key things it's trying to kind of point out to me. Some of the virtual machines have temporary disks. We talked about this. If it has that little d modifier, it means it has temporary storage. If we go and look at mine, this is my actual virtual machine. If we go and look at Explorer, one of the things we see up here is temporary storage. So this VM does have a temporary disk, and it's trying to help you. It calls the disk temporary storage, and it even has a file at the base of the drive, data loss warning readme. And what it's basically going to tell you is you're going to lose the stuff if you put it in here. This is a temporary disk. Any data stored on this drive is subject to loss. There is no way to recover it. I don't put stuff on this disk you care about. Like, the only stuff you should be putting on this disk is stuff that you just do not care about at all, because this local disk resides on the host. So remember, when we talk about the structure, my virtual machine is running on a physical host. The temporary disk is using local storage to the host. Well, if I stop my virtual machine and stop paying for it, it's deallocated from a host. Whatever was on that VHD file that was on the local storage of the host is deleted straight away. It's gone. Microsoft cannot get it back. So do not put anything you care about on the temporary storage. It's great for maybe some caching stuff. Windows sticks the page file on it, sure. But never ever put D does not stand for data. It's a temporary drive that's good for temporary storage, but nothing at all you ever actually care about. You can add additional data drives. And again, you get to pick the cache options. I can hot add remove these. There are metrics. So there's a whole set of different metrics available to you as we go and look. This is a time series database. So if I go and look at my monitoring, and there's even guest metrics you can enable as well. So you can see these are ones that come from the host. So there's virtual machine host metrics. So these are things that the Hyper-V host can see. And this gives it the ability to peek into the memory that it's using. I can look at potentially the data throughput. I can look at OS disk capabilities. I can look at the percentage of CPU it's using. So there's a whole set of nice metrics. There's also the ability to peek inside the guest, if these are enabled, to go and see things about logical disks. Because remember, the hypervisor doesn't understand what volumes I'm creating on a mapped disk. So these have to come from the guest OS processes. The hypervisor can't see the processes. So those things, they again come from the guest information. And one of the cool things you can do is it had this apply splitting capability. So you can then work out, well, what do you want to split it based on? So split it based on like the VM or VM scale set, how you want to sort those things. So there's the ability to really do some interesting things when you actually go and look at the various metrics in your environment. So these are free. They're just time series metrics. There are other types, remember, available to you, which is where I have to use diagnostic settings. So diagnostic settings can let me go and send things to other places. I can go and send it to an Azure Monitor Workspace, App Insights. There's other types of configurations I can do to grab other types of logs. But you get those base metrics just free, and it's just all as part of that regular Azure time series database. So we have a whole set of metrics that help us see what's going on, not just at the hypervisor level, but I can enable those guest metrics as well. There are a huge number of extensions available. Now, remember we talked about responsibility. So, hey, your responsibility is for patching it and the backup of it and the replication of it and the configuration and all the whole list of different things. But there are services in Azure to help you with those. If, again, we jump over and look at a virtual machine, one of the things we have is extensions and applications. And if I look at the extensions, I've got a whole bunch of them. So I'm using the ability so I can auth directly to Entra. I've got Azure Monitor Agent. I'm tracking changes. I've got a dependency agent to work out what things are talking to each other. I'm enabling Compute VM Access, Guest Health, Windows Agent. I've got anti-malware running. other types of insights, but there are a massive number of extensions available to help you do various things within your environment. I can define applications, and I can add up to 5 applications from a gallery, and we'll talk about this a little bit later on. But I can layer down applications that I'm maintaining in my environment. There's all these other types of services. So I can run a command. I can set up an auto shutdown. It can help me. Depends on the image. I don't think mine is supported with the Azure Update Manager and hooking into these things. But different types of image have supports for Azure to help patch it, either in a more automated fashion or more orchestrated through Azure Update Management. I can look at my inventory. I could apply configuration management. I can look at the changes to my environment. I can get insights through things. There are automations and tasks that use logic apps. Like, there's just a crazy number of different things that are available to help me with my virtual machine. And the resource visualizer is kind of cool here, that it can help me actually visualize that. Oh, I think I zoomed out in a bad way. Let's get that back. So I've got my VM object, and I've got my disk object, and I've got my network interface object. And you can go and dive into that and look at other cool things all around that. So it helps me understand what are the various aspects of my total environment. So there's many things, and I'm showing it in the portal. Realize I can do these through templates. I can do this through infrastructure as code. Generally, I don't want to be going and creating all these things, just click, 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 click. You want this to be infrastructure as code, so it's in a very consistent, declarative manner. Those automations I talked about, hey, automatically stop it, automatically start it. There are virtual machines that have InfiniBand, super high throughput, low latency connections, which I'm going to use for high performance compute. There are ones with GPUs, the N series, for example. There are ones with NVMe local storage, like the L series. Using availability sets, availability zones, proximity placement groups to try and keep things as close together to reduce latency. Managed identities, both user and system assigned, which we talked about in the identity module. The ability to then processes inside the VM to automatically, just as an identity native to the resource, to go and talk to other things. Avoids me having to store secrets. And then on-demand capacity reservations. That's a really useful capability when I need a guarantee capacity will be available in a certain, maybe AZ of an exact SKU. We talked about the idea that Azure has to maintain like a certain amount of idle, which makes available a spot. But realize if my needs are super, super specific, it could be at a certain moment in time, and I need a very specific SKU in a very specific AZ, for example, maybe my provision would fail. It's not common. But if there was a run on the bank scenario where many other customers all at the same time rush to create a certain SKU, your start may fail. Again, it's not common, but it could happen. Things like Azure reserved instances is not a reservation of capacity. It's a reserving a price based on a commitment to use a certain amount of something. It does nothing to guarantee the capacity will be available for you. The name is terrible. It shouldn't be called reserved instance because people think it means they're reserving capacity. You are not. You're reserving a price. If I want to guarantee a capacity is always available, that's where you use the on-demand capacity reservation. And then I create my resource into that capacity reservation. It's adding an SLA for the ability to create that virtual machine. And then other things can build on top of that as well. So if I'm concerned there's this critical resource I must be able to create, that's where that on-demand capacity reservation can come in. What about supported operating systems? Well, Azure will not support an operating system that is not supported by the vendor. For Windows, they generally support all of the various SKUs. Now in Azure for Windows Server, you're always going to use the data center SKU. the way the pricing and the features work, there's no point in not using data center. For the client SKUs, there were some special requirements for its licensing. But if we go and look, except for the hybrid benefit, the license cost for any Windows VM is identical. Therefore, you're always going to use the data center edition. And it's saying Windows Server 2003 and later. So Azure actually has some extended support that you can't get outside of Azure. But they're going to have images specific to the supported versions in the marketplace. And then now it's talking about which particular roles are going to be supported, features. It goes through all the details. And when you go and create a virtual machine, you'll see. So it's got recently used, but recommended. So you can see there's Linux ones here. There's a whole bunch of Windows. So I can see, well, there's Windows 2022, 19, 16. There's Windows 11 Pro, 10 Pro. But I could see all images. And now I'm in the marketplace. And I could say, well, operating system, I don't want all. I could trim it down to the exact ones I want. So, and remember, some of these will not be Microsoft. There are not 684 Windows Server 29 from Microsoft. Other people can go and create images. Let's have a look. So some of these are coming from other companies. So if you keep scrolling down, tool for office reporting, but it's built on Windows Server 2019. So you always want to pay attention to the vendor, because just because it's got a name sounding like, oh, it comes from Microsoft, it doesn't mean it is. So you always want to check that. But obviously you could check the publisher type here, and you can say, hey, I only want to see the official Microsoft ones. And now these are the ones that are Windows Server 2019 from Microsoft. But then there's kind of the basic one over here. You can see there's other types of options available that I can use. You see server core, where it's stripped down, no graphical interface. There's ones with the GUI. It's really down to whatever you want. There's a whole set of different Windows ones in here. Likewise, there's a whole set of Linux distributions. CentOS, Debian, Red Hat, SUSE, Ubuntu. There are others, because there were some newer ones. I think there's Rocky Linux. There's a whole bunch of other ones available now that will work in Azure. In fact, let's just jump over to the next slide. So for Linux, there's a whole set of what distributions. And Microsoft made a whole bunch of investments to the Linux kernel. So a lot of the things around Hyper-V, they're built in. You don't have to do anything special afterwards. So Alma Linux, Ubuntu, Debian, Flatcar, Oracle Linux, Red Hat, Enterprise, Rocky Linux, SUSE. And there's a little warning about CentOS because they basically retired that off. And you see a lot of people now going from CentOS to something like Rocky Linux, for example, or Alma Linux. You're seeing a lot of those switches because they're highly compatible. There are a lot of different images available in the marketplace. You can bring your own. You can absolutely either, for example, create a virtual machine and then generalize it if it's Windows, which means it removes the unique identifiers for it. There in Windows images, there is a KMS in Azure, so it will activate. You make sure you use the right key, but it will activate in Azure just fine. You can create it on premises and then bring it to Azure. There's a whole set of different things you can do there. And then obviously you manage the various apps and agents inside. What about if you want to be an only child? What does that mean? Remember, you're in a multi-tenant hypercloud. They are not deploying a box for you which runs your virtual machines. You are isolated by the hypervisor and the various security protections they put in place. So one VM can't go and look at another VM. There's huge investments, and that's the point of a hypervisor. But maybe you don't like that. So There sometimes is a little bit of benefit for maintenance purposes if you're on your own host, but honestly, that's not a big driving point today. There's a lot of good flexibility you get anyway today with maintenance capabilities. So I wouldn't want to go and create my own host type SKUs just to control maintenance things. But there are isolated virtual machines. So what does an isolated virtual machine mean? And then there's dedicated virtual machines. So an isolated virtual machine, let's go and look at what these are. An isolated virtual machine is basically one that takes up the host. It's so big, it takes up the host. Now notice the word current, because it could change. Notice also here there's a deprecation of isolated VM sizes. So these are ones that used to be, but are not anymore, either because they're aged out or realize, what does an isolated virtual machine actually mean? We always talk about the underlying host. So, okay, so there's an underlying host, and that underlying host has its dimensions. It has a certain number of CPUs in it, has a certain amount of memory in it. An isolated VM is one such that its dimensions, so its virtual CPU, its memory, take up the box. Obviously, there's a little bit left over for the hypervisor to do stuff, but it's such a big VM, another VM can't fit on it. And so that list of the current virtual machine sizes that take up the whole box onto which they are placed. Over time, realize, as boxes maybe get bigger, well, this SKU no longer takes up the whole box. They'll give you lots of notice about that, but that's what an isolated SKU is. Okay, but then we saw this other word, dedicated host. And if we look at dedicated host, what's different between a dedicated host and an isolated host? So a dedicated host, you pay for a certain type of host. And you'll notice it aligns with the different VM SKUs. Okay, there's a DAS v4 type 2, which has a certain amount of virtual CPUs, a certain amount of memory. And there's a DDS, there's an EC, so confidential, there's an EB. There's all these different types of dedicated hosts which have a certain amount of CPU and memory. Why? Well, these all seem to align with the virtual machine SKUs. So what you're doing here, as the name really suggests, is with dedicated host, well, remember we talked about hosts are designed based on the different ratios and capabilities of the virtual machines. So with a dedicated host, it's of a certain series which aligns with its dimensions. So it has a certain number of CPUs, it has a certain amount of memory. And then what happens is you're paying for the entire box. So this is yours. So this isn't shared between anyone else. You are now paying for the entire box. What you can then do is create VMs inside of different sizes, but they have to match the same series. So if this was a, excuse me, I don't know, DDS v5, well, I could create a DDS v5 with 8 virtual CPUs. I could create one with 4 CPUs. I could create ones with 2 CPUs until I fill up the dimensions of my box. I can do any combination I want, but the series has to exactly match the series of the dedicated host. They have to be the same. So I couldn't buy a host that was DSv4, then try and put an EVM on it. So it's the idea that, hey, maybe because there's regulatory requirements or something else, I'm super picky about the things I need to have no one else running on my box, basically. I have to be ensured I'm the only person regulatory is driving it, or I'm so paranoid, it's so important, I can't risk, even though nothing is known, some, hey, cheating thing that tries to go by the hypervisor to peek into another virtual machine, cannot risk it. That's what the dedicated host lets me do. I own the entire host for that. Azure Local, of course, is always an option. So there was previously like Azure Stack Edge, Azure Stack Hub. There were a whole bunch of different things available, Azure Stack HCI. They've all now falling into the term Azure Local. And the point of Azure Local is it leverages Azure Arc, which we'll talk about, but it's from form factors to a very small ruggedized device through to a multi-rack system, but it's on your premises or your colo that you work with. So it's bringing certain Azure services built on VMs and Kubernetes to your location. So of course, that's not shared infrastructure. That's now your infrastructure where I can run Azure services in your environment. So that's the whole point of that. And then on those virtual machines and those Kubernetes, they bring other types of Azure services. So there's things like the virtual desktop, some of the data services, maybe some of the app services, some of the AI capabilities, but now they're running in your environment. And then we do have Azure Arc. So Azure Arc, ARM is the Azure Resource Manager control plane. When I use Azure Arc, it extends that control plane into my operating system instances, my CNCF compatible Kubernetes instances. So now those resources become known to the Azure control plane. I can then bring features like tagging because it's now a known element. I can have role-based access control. I can get certain insight into the resources. I can get monitoring. I can bring services to those Azure Arc instances like the data, the AI, app services. So it's another way that, hey, it's my OS instance or my Kubernetes cluster, but I want to extend Azure capabilities and management to it. So I'm now controlling that. There are also some bare metal offerings. These are not super common. Generally, the hypervisor doesn't add any overhead, but there might be certain workloads where maybe even from a supportability, they don't like you having a hypervisor in place. And so there is bare metal. The bare metal is really based around SAP HANA today. I think also some of the Nutanix offerings, they leverage this as well. But you basically get these bare metal boxes that directly runs these particular solutions that support bare metal. Again, it can change over time, the exact ones that it's using, but I'm getting these bare metal boxes that runs a very specific workload. I cannot just buy bare metal and say, hey, I just want access to the box and do whatever I want on it. You cannot do that. It's for very specific workloads. But hey, if I cannot have that sharing or doesn't want the hypervisor in place, if it's one of those supported workloads, then I can use the bare metal capability so that is available to me. Maintenance considerations. Realize Azure itself has a certain amount of maintenance it has to do on its hosts. Now, it does use Hyper-V. It is using Windows Server, but it's a very specific scaled down version. There are certain features that are different from what you go and buy with Windows Server, but there is a lot of joint engineering between them. Some of the features you see in Azure then come to the Windows Server Hyper-V. Some of the things Windows Server Hyper-V does then comes to Azure, like some of the hot patch things started in Azure, but now it's going outside of those. So there's a lot of co-innovation, but even with hot patch, there are still times there is maintenance required on the hosts themselves. Now, depending on the type of host, so I can think about, hey, your VM can hit types of maintenance. There's planned. Sometimes it's going to require your VM to be impacted. Now, they try not to. Sometimes they can actually live migrate your virtual machine. It depends on the SKU, and it tells you. Remember, we looked at the VM and it said live migrate. It tells you whether or not Azure can live migrate your virtual machine. Some of the ones that, for example, historically like high performance compute, the ones with GPUs in them, something the G, H, M, N series, they couldn't be. So then they use virtual machine preserving host update. What that does is it's kind of cool. So normally if I reboot the hypervisor, well, the hypervisor is controlling a lot of the things. The VMs have to reboot as well. What preserving host update lets me do is it freezes the memory of the VM reboots the hypervisor. So the VM can't run because the VM can't talk to disks or network, but it freezes the memory state, reboots the hypervisor, reboots the management partition, which is probably the thing being patched. When it comes back up, the VMs unfreeze with their memory in place, so it doesn't have to wipe the memory. So maybe there's a 30-second impact. But that's a really nice capability to not impact your virtual machines in a hugely negative way. But that's why they always say you want at least 2 instances of any workload, because there is both planned scenarios and there's unplanned. I mean, things fail. It's the cloud, but it's not magic. The cloud is made up of someone else's servers primarily. So there's racks and there's servers inside them. Disks can fail. Power supply units can fail. There can be data center level failures. And yes, they architect these things really well. There's huge redundancy in the network switching, in multiple power supply units, battery backups, generators, water backups. They have huge tanks of water to survive interruptions to water, huge fuel tanks to run the generators for days on end, multiple contracts. But fantastic stuff. But I can still have a failure. I mean, it just happens. So if I want the true resilience, it's why we always want at least 2 copies of any kind of workload so we can survive some kind of interruption. So there's unplanned hardware, there's unexpected downtimes. I mean, these things happen. So that's why we use availability sets. We use availability zones. We have multiple regions that can help minimize the impact of anything we need to be doing. One of the nice things from a plan perspective is they won't do the availability zones at the same time. So they'll roll the things. So by using availability zones, the planned maintenance won't impact multiple instances of whatever I have if I spread them over availability zones. If I'm using availability sets, if I spread them over fault domains, which is the point of an availability set, it won't impact them at the same time. Historically, head regions, they would say, would not be rolled out at the same time. But honestly, availability zones is the thing to focus on today. If you look at some of the tail, like the time it takes to roll out some changes, it takes longer than a day anyway. So the idea that, okay, the paired regions, they have a day gap between them, I don't particularly find that reassuring anymore. I would focus way more on the availability zone constructs and understanding sort of the testing that's going on behind the scenes. Don't forget your own reboots, right? There's still the operate Azure, unless you're using like Azure Update Management or Azure's capabilities to patch for you. They're rebooting their infrastructure, their hosts. You still have to take care of your operating system, your Linux, your Windows. So don't forget, you still need in the guest to have some kind of patching going on. So don't forget to have a solution as part of that. Speaking of which, I mean, there are different patching solutions. There are different approaches available to you, but patching is critical. Realize when I think of security, patching is probably the number one thing to do. Most attacks are against something that's been patched already. So make sure you're staying current in a safe manner. And what I mean by that is we don't ever think about patching everything all at once. So yes, it's important we patch, but what I don't want to do is, hey, if I think about I have my environment, and I just said we want multiple instances of whatever thing I have. When I patch, what I think about doing is building confidence. And it's not just patching, it's any change. Any malware definitions, changing the SKU to a different size, any change to the app. I want to build up confidence that nothing bad is going to happen as a result of this. So I would always think about, well, obviously you've got your own dev test kind of environments first, which is non-production. But then for production, I'd think about a small ring, then maybe a bigger ring. I get these gradually increasing rings that I roll my change out to build confidence it's not going to have a negative impact. So always have safe deployment practices to ensure, hey, look, whatever the change, patching, config, SKU size, doesn't matter, anything, you want to go through that safe deployment process. So really good testing. Maybe you got blue-green, you can switch environments, but never do a thing to everything at the same time. I always want to think about very controlled, orchestrated, good gates to ensure the quality and it's not having an impact. Maybe a gate is how many tickets are being raised, how many alerts, what sort of abnormality am I seeing between the performance and my benchmarks performance. I want to assure the quality of what I'm doing and hey, it's going bad, let's just keep going. Never want to do that. So there are different approaches. I can just let the guest OS do it. So remember, inside the guest OS, like in Windows, I can say, hey, automatically apply updates. But realize what that means. If I'm doing it automatically inside the guests, they're not coordinating in any way with each other. So they might all pull the patches down at the same time. And if there's a problem, they're all going to go bad at the same time. So generally letting the guest just do it on its own is not a great option. So then I can think about, I can use a third-party tool. Now, obviously, there's things like System Center Configuration Manager. I think Microsoft's retiring WSUS, but I could use some third-party tool to do that orchestration, to create groups of machines, approve the patches, roll them out to a portion, then continue. I can manually do it if I hate myself. There's always an option. If you have more than one VM or even one, that sucks. I don't want to do that. Azure can do automatic guest patching via an orchestration. So what this will do, it's using an automatic guest agent. So it's using the Azure VM agent and an additional patch extension. But it's going to use availability constructs as part of the rolling out. So what it's going to do is maybe update domain by update domain availability sets, AZ by AZ if I'm using availability zones, region by region. So it won't deploy everything all at once. It's still fairly simplistic, but it will at least follow availability first principles as it rolls out the changes. And it's not using an Azure native source for the patches. It's still going to use whatever your source is. If it was WSUS, it's still going to use WSUS. If it's Microsoft Update, it's still going to use Microsoft Update. If it's Linux, if it's Ubuntu, it's going to use apt, Red Hat, Yum, SUSE, Zipper. I'm not changing the repo. So whatever you've configured as the package manager, the source of truth is still the source of truth. This is just kicking off monthly, going and looking for security and critical patches. That's all it's going to do. Works for Windows and Linux. Within 30 days of being released, it's going to get deployed and rebooted. It's going to use the standard off-peak time zone for the virtual machine. And hey, it's just going to try and ensure keeping your workload running. Same sort of stuff it does with updating images in scale sets. So it's going to keep things as good and running as it can. So I've already talked about this. Then there's also Azure Update Management. Now that replaces the old update management solution that existed that uses log analytics and runbooks. It now uses just the Azure Resource Graph. It has its own extension for Update Center. It also can support Arc-based machines, so it doesn't have to be in Azure. But this is a more powerful solution. I can choose the types of patch I want to install. It's not just critical and security. I can control the timing of the application of the patches. I get a complete history as logs of the operations it's doing in the Azure Resource Graph. It supports hot patch. So hot patch is a component for Windows that even if it's the kernel, I don't have to reboot. There are many types of things now. It can patch the kernel in-memory components while it's still running to reduce downtime. So if I want additional control, if I want to be able to create groups of machines statically or dynamically based on some attribute, if I want to be able to have greater control of how it rolls those out, if I want to be able to approve particular packages of patches, well, that's what the Azure Update Management solution does. So that's the goal behind that. The instance metadata service. So this is something that inside the guest operating system, so if I'm a virtual machine, a process inside the guest, what I can do is, let's do this special color. So we have the Azure Resource Manager. So we have Azure. So there's this service called the Instance Metadata Service. And the way we use this is it has a specific IP address. So if I talk to 169.254.169.254, that's not me remembering it, they repeat it. So anything within here can talk to this. And that IP address is representing the Instance Metadata Service. You might have also heard of 168.63.129.16. That's the Azure DNS address. So I have this special address. And what this lets me do is from inside the operating system of a guest, basically find out information that the control plane knows. So the virtual machine's information, I can go and ask, hey, what is my SKU? What are the tags associated with me? What are the things I can actually have here? So if we're going back to our virtual machine for a second, just close this down. I think this was actually hanging. So notice there's different ways of doing this. First, I'm going to start with invoking a web request, which is not a very good way of doing it. But notice I'm talking to 169.254.169.254 metadata. And if we actually scrolled over, talking to a certain API version. And if we just run this, notice I don't have to authenticate. I'm running inside the OS, and I'm just talking to the metadata endpoint. If I actually dump it out, this is all the stuff that it's being told by the Azure control plane. So now it knows quite a lot about itself. So inside the guest, well, I know I'm running in the Azure public cloud. I can see, okay, I'm a client license. I know what region I'm in. I know my name as a resource. I know my computer username. I can go and see, okay, my physical zone. So I'm in AZ3 in US South Central. I could see various fault domain, what provider I'm talking to, what is the image that I'm using, my resource ID. Okay, what is the image and disk information I have? What tags do I have? Keep scrolling down. There's my tag list, business unit, cost center, environment, OS. User data, we'll come back to what that is. My VM size, network information. Like it gives me the ability to see a whole bunch of really cool stuff. Now that was using web requests, which is kind of ugly. The other thing I can do is actually instead, I'll just use invoke REST method. I can still convert that to JSON and then I could spit it out. I'm going to see exactly the same thing. It's just invoke REST method will give me a nice PowerShell object. And so this $response, we'll see this in a second, is now a nice PowerShell object. Now I can just ask for specific areas. So I could just ask for compute information. I could just ask for the tag list. So I do have the flexibility to just get certain stuff. So if I just ask for the tags, for example, now it just dumped out my tags. That response I got earlier, because I used the nice REST method, it's just a PowerShell object. So I could just look at the computer name. I could just look at the resource group. So here I can just dump out, oh, there's my VM name, resource group, and my virtual machine size. There's also a concept of user data. Okay, so let's look at my user data. Well, it's encoded. Well, then I can just decode it. Hello, test 1. Okay, what is this? So one of the things I can do in the control plane, Azure Resource Manager, is for my virtual machine, if I go and look at my settings, operating system, you have the ability to set user data, and I set mine to hello test 1. Now, you may look at this and think that is really, really useless. Consider a scenario, though, where maybe I'm creating multiple VMs and I need different VMs to have slight differences in their configuration. And I don't want to have to plumb in and connect into each VM to set that particular role or some particular unique bit of info. Well, now I can just set that. I can just set user data through the Azure control plane as I create the resource. Then inside the guest, I can read that data and then maybe change my configuration based on what those things actually are. So that's actually a super powerful capability that the instance metadata service lets me take advantage of. So I think that's a really nice thing to use. I can also get information about the virtual machine. So for example, the creation date. I could go and look at what's the creation date from the Azure outside of the virtual machine, so I can find out stuff about the VM as well. IaaS PaaS Lite. There's something called Azure Automanage. Remember, with infrastructure as a service in a virtual machine, I have to think about the backup, the patching, the inventory, change tracking, security services. Well, what Automanage does is based on a configuration profile, really production or dev test, it takes care of what are the core services I would want for dev test versus prod. Windows and Linux, Azure and Arc-based resources, because the configuration profile will be different. I want different things from production than I would want from a dev test environment. I can create custom ones as well. So if I go and look at Automanage, we can see the services that it includes. So backup, it only works for production, doesn't do it for dev test. But Defender for Cloud, well, it uses that for production and dev test. So it gives us different services that make the most sense depending on what it is. And again, there's ones for Windows Server and also Azure Arc-enabled services. So I get those different capabilities. It doesn't cost me any extra to use the Automanage. Obviously, I have to pay for the underlying services. So it's helping me get those up and running. There's no virtual machine scale set support today. That could change in the future. But helps me worry less about the things, and it goes and sets up the things I need to be in place. We have the compute gallery. This was formerly known as the shared image gallery. Think of it as I want my own images, or I want my own application definitions that I want to use in my environment. And it gives me the ability to have versioning. So I have different versions of my image, different versions of my application, and make them available to different regions around the world where I might want to then go and create resources from it. So it works for images, so operating systems, but it also works for virtual machine applications. And the way this really works is you have an image definition. So if we jump over, let's start looking at one. So if I look at my Azure Compute Galleries, I've created a gallery. And in my case, I've got images, but you can add an image definition and an app definition. There's no version yet. This would just be the definition of one of these things. So an image definition, you would be telling it, well, a name for what I want to create. Is it Windows or Linux? Gen 2, based on the type of VM that I'm supporting and selected here. What is the OS state? Then I give it a publisher SKU. Now I can actually go and create a particular version of this virtual machine. I would point it to a certain source. And then you get various publishing options for this, information about the virtual machine, image, etc., etc. But here I've got one already. So this is my definition. And then in my case, I have one version of it. And with a particular version, one of the things I can do here as part of it is I can set the replication. So right now I've got one copy of it in South Central, but I might want to increase the number of copies of it. For example, if I wanted to be able to deploy 100 VMs from this image at the same time, well, I probably want more replicas because that will put too much stress on the particular copy of the image. The recommendation is 1 replica for every 50 concurrent deployments. So if I was going to do 100, I would want to change this to 2. If I want to be able to deploy VMs in East US, well, I'd go and add some replicas in East US as well. So based on the particular image version, I go and add replicas. So if we look at the structure of what we're doing here, I have a certain region. So I have my region. And what I create inside there is my compute gallery. I can then do 2 different types of object. So I can think about, okay, well, I'm going to do a VM image, but this is just the definition. So the definition, as we saw, is like the name, a description of it, architecture. And then I'm going to create 1 or more versions of that image. And that has a certain number of count of the replicas. But the other thing I can add here, remember, is I might want a certain number of counts in other regions. And to create a particular version, there is a source. So I've got a blob, for example, storage account or whatever that is, could come from the marketplace. I might take a VM image snapshot. Again, it could come from the marketplace. But that source makes up a specific version that I'm making available through the compute gallery. So then, hey, people could go and create stuff from that. The other thing I have in here is, so okay, that's the replicas of that particular version. I could obviously add a new version. If I was to add a new version of this particular image, what it's going to want is, well, where's the source coming from? So I could say it's from a storage blob, it's from a certain VM image version. I've got a managed image that I want to use. I've got a disk or a snapshot or something. And that would be a new version of this particular virtual machine image. I could create a VM from it. I could create a virtual machine scale set from it. But then I can also create applications. So an application is going to follow a very similar idea. So I have a certain definition. And then I'm going to go and add a version of it. And that version will be stored in a certain blob. But also notice for an application, there has to be a way to install it, uninstall it, and update it. So there are some other commands I need to do for an application. And then I can take this application, and I think it's up to 5 of them deployed to a virtual machine. So I've got VM image definitions, but I can then also do VM applications. And as part of an application, I have n numbers of versions. And that version has the package, the files that I need to actually install it. So like an MSI file or whatever that is stored in a blob, so a storage account. But then additionally, I'm going to give it the commands. And the commands is, well, how do I install it? How do I uninstall it? And then how do I update it if I've already got a version installed? And then what's really cool is I can then link those applications to a virtual machine. So now I start to build up a complete usable environment. So, hey, I've got my VM image, which is the base. I don't want to put the apps in the image. I want to keep it as generic as possible. So I don't want to maintain hundreds of different images. So I have fairly generic vanilla images. And then I layer on the configuration. I layer on the applications that I want to be able to run inside it to actually then go and create my complete environment. So that's how we think about using all of these different things together. I think it's a 1 GB max size per application. And obviously, there's other ways you go and trigger other types of commands, etc. But one of the great things is once I go and create all of these things, you can share them across subscriptions and tenants. So when I create a gallery, I get to pick what is the sharing I want. So there's regular role-based access control. So I could maybe go and share it with particular people. But if I go and look at my compute gallery and create a new one, you notice sharing, there's actually the ability to just go and share directly. So users in just the same tenant and even different subscriptions and different tenants. So I can be very specific about how I want to share this particular gallery with various groups of people, and they would all have read access to that. But I could also think about creating a community gallery that is just available basically to anyone. So think public scenarios, I could use the gallery to just make stuff available out to anyone out there. So lots of different options. Azure VMware solution. Now, as we talked about before, Azure runs on Hyper-V. It's not using ESXi, it's running on Hyper-V. And you don't care. You're never interacting with the hypervisor. You're interacting with the Azure Resource Manager, which is the control plane. And I use the Azure control plane to go and create resources, manage resources, etc., etc. But there is a certain learning curve to be able to start using Azure. Now, generally, you want to be using that Azure control plane. Use the Azure native capabilities, use the Azure native resources. It gives you the best integration, the best capabilities. However, there may be scenarios where I need to quickly vacate a data center or quickly vacate a licensing thing I'm under, for example, with Broadcom VMware, and I don't have time to retool. The human beings don't have time to learn Azure, or they want to later down the line, but for right now, I just want to move these VMs to somewhere else. And so that's what the Azure VMware solution is. It's a first-party Azure offering, so it's running in Azure data centers. It is made in partnership with VMware, but it's using the VMware tooling. It lets you carry on using vCenter, for example. You don't have to relearn the tools that make this up. And what this is actually going to look like, so what I would do is I would create an Azure VMware solution instance. Now it's going to live in a specific region. So I'm in a region. And it's all based around the private cloud concept. So this is going to create me a private cloud. Now within that private cloud, I can then create n numbers of clusters. So I've got my private cloud, and I'm going to create a cluster. Remember, I can have between 1 and 12 clusters. My cluster is made up of hosts. And it's between 3 and 16 hosts make up my cluster. So you can see I've got quite a lot of flexibility in the makeup of that. So I can add and remove nodes, and I can use my familiar tools. Now, what this is doing, as you would fully expect here, it is using ESXi as the hypervisor. It's using vSAN for the storage. Now, additionally to the native storage where it's using the storage inherent to each node, it can also hook into some external. Now, it could go and talk to regular Azure services from the apps inside, but I can use things like Azure NetApp Files. I can use Azure Elastic-SAN to make those raw building blocks of additional storage available for the actual volumes. It's using NSX for the networking components. But then I want to think about, well, connectivity. What's the rest of the connectivity looking like? And it's ExpressRoute. because this is not running regular Azure at all. These are ESX hosts running, yes, in an Azure data center, but it is not connected to your regular virtual network construct. There is no concept of that at all. So what's happening here is when I want to go and talk to other things, we use ExpressRoute. So if I think about a Microsoft Enterprise Edge, this is the Microsoft, and we have an edge. My private cloud connects to a particular ExpressRoute circuit. Now, through that, I can go and talk to potentially other things which have their own ExpressRoute circuits in Azure. But additionally, what you're going to have is your on-prem. That's the wrong color. You have your on-prem, which is not orange, it's green. So these are your premises. And you have, remember, your ExpressRoute connection. So that's your circuit. And we use something called ExpressRoute Global Reach. So ExpressRoute Global Reach lets me talk via the ExpressRoute backbone and different circuits and connect them together. So now I'm on premises, and what I can now run is, for example, vCenter to manage my Azure VMware solution. I could run tooling. So I could do things like bulk HCX. I could do bulk live migrations, for example, using these capabilities. So this is available. I did a whole deep dive video on Azure VMware solution. Me personally would rather you get to Azure native constructs, but that takes time. So I think of this as, look, I just need to get out of my data center as quick as possible. I don't have time to retool. This is where this is phenomenal. It gives me that ability to quickly move out of my data centers and not have to relearn anything. And then maybe it buys me time, and then I could start moving these things to Azure native constructs. So it's there as a capability. Second final thing, virtual machine scale sets. Because often, in fact, nearly always, I don't want one of something. In Azure, we don't like one of anything. Minimum, I want two. So I want to be able to put them on different availability zones, different fault domains, because there's planned failures, planned maintenance, unplanned failures. Things happen to stuff. So I always want more than one of something. And very often, I don't just want to create 6 of a thing, because my workload varies. And in the cloud, we pay for on a per second basis when something's running. So really what I want to do is have this automatic scaling and add and remove instances based on the workload that's coming in. So I want this capability. So I would think about, okay, if we're going to talk about virtual machine scale sets, the idea very much here is, okay, well, I have a minimum number that I ever want. Maybe I start off with a certain number, but I want to be able to add and then remove as the amount of workload changes over time. So the whole point of what I want to be able to do here is automatically scale. And this is horizontal. I'm adding and removing instances of the thing. I'm adding and removing web servers. I'm adding and removing some batch process based on the work that's coming in. Vertical scaling would be changing the size of the instance. And that's a lot harder to do. It is possible, but there'll be some downtime because I can't add CPUs or memory. Most OSs don't work particularly well with that. Most applications wouldn't recognize it. So generally the pattern we want to use and to avoid downtime is we just add and remove instances, and these would all be behind some load balancer, remember. So people are not talking directly to these. There's some entry point for the client or the tier above it, and then it gets balanced out based on the actual ones that exist at any moment in time. So we're adding and removing those instances. Now, how we're adding and removing those instances, well, that's where the virtual machine scale set comes in. It's the orchestration. I could think about, well, look, I can look at different metrics of what it's doing. So I might say, well, look, the CPU is hot. If the CPU is greater than 70%, let's add 2 new instances. But likewise, if the CPU is less than 30%, let's remove an instance. And you want a certain cooling off period between actions because it takes time to start them. It might take time for the load balancer to see them there and start sending traffic. So I don't want to be scaling too quickly. Maybe there's a 5 or 10 minute window between any scaling action. But hey, they'll be adding and removing based on how busy if CPU is the thing. There are other things. I might have, for example, a bucket of work. I might have a queue. So I might say, look, if the queue depth is greater than 50, go and add an instance. If it's less than 1, let's remove an instance, i.e. 0. Less than 1 is not that descriptive. But you get the point. I can use different things to configure how many instances I have at any particular moment in time. So there's different options I can do there. And that's the point of the virtual machine scale set. What it's going to let me do is, as the capacity varies, add and remove. Now, there are 2 modes of orchestration for VMSS. There's the flexible, which is the newest one, and then there's uniform. That's legacy, but it is still supported. Uniform only supported a profile, and everything had to be exactly the same thing. Flexible gives you flexibility, that I can have a mix of different SKUs and spot and non-spot. But the basic idea would it be, here I'm saying it's going to create these virtual machines. The way it does that is you have this idea of your profile. So I have my profile, my gold image. So I have my image. I have the particular VM SKU. I have the VM configuration, what extensions I want, etc. So this is the profile that the virtual machine scale set is using to then go and create and remove them. Now, I talked about there's these 2 different modes. So in uniform mode, it's only that. You have a profile. Every VM in the VMSS has to be exactly the same SKU, spot or non-spot. There's no mixing of them. It is the same thing. The new one is flexible. Now, in flexible, I can still have a profile, and you probably will, but it's optional. But I can also add my own VMs. I can mix spot and non-spot. I can mix SKUs. And it treats the virtual machines it creates as regular virtual machines. With uniform, I can't use the VMs at an Azure control plane as regular VMs. They're this special type of object. With flexible, it is creating regular virtual machines. They're trying to move away from this concept of some special thing. And so generally going forward, you're going to want to use flexible if you can. Now, when you create these things, there's something called a fault domain equals 1. And if you do fault domain equals 1, it just means spread them out as much as you can over as many different racks as you can. Availability zones, you're typically only ever going to see 3. I can have up to 1,000 instances with flexible from a regular marketplace image. I think it's 600 if you use a custom image. I can add all the different extensions. I can do amazing things with the scale capabilities. It can even do forecasting. So one of the cool things virtual machine scale sets can do now is based on history. It can scale up in advance before you get the peaks using its predictive capabilities. So I could say, hey, based on the past, 5 minutes before you're expecting a peak, I want you to scale up and avoid having that slowdown when you initially get the burst. You really want 15 days of historical data to be able to use that, but I think 7 days is the actual minimum, but it's a really great capability. If we go and looked at one just for a second, so let's jump over. So if we go to if we want to create a VM scale set, it gives me this choice, flexible or uniform. Now, through the portal, it's always going to guide you to create a profile as well. You don't have to. Notice it's going to give me a choice of, well, what's the instance details? Because this is going to go and create the profile. If I'm doing this through a template, I don't have to specify this. Again, with the flexible, I can just add VMs manually directly into the virtual machine scale set, so I don't have to do this. I can pick, hey, do I want to use spot and on demand? Because again, I'm using flexible. What I want to do in eviction circumstances, how I want to do scale, what I want to distribute between spot and non-spot. Because remember, spot could be kicked out. So this is, hey, how resilient do you want to be if spot decides to run out of capacity and you get evicted? So maybe I'll say, hey, 20% use spot and the rest of it don't. I have all the same configuration options, etc. But I'm basically defining what is my gold image and then define all those scaling options around it. So this does work very differently from uniform because I can just create an empty set and then I can add any type of virtual machine, including that spot, non-spot mix. I can have that profile if I want to, but I don't have to. That's really the big deal here. I don't have to have a profile. I can just create the virtual machines and add it into it. Flex will actually provision faster as well because it's using newer APIs behind the scenes to leverage this. VMs are just virtual machines. They're not this special weird thing anymore. It's just a VM is a VM. A few good to knows, I think, about virtual machine scale sets in general. It's going to give me the ability to still use fault domains and zone balancing between all the different things I'm doing. So it's going to use 5 fault domains if it's regional and I'm not using zones. But if I do that, fault domain count is 1, it's going to spread them out as much as it possibly can. It's best effort, but it's going to just do as maximum percentage. I can have that spot mix, so I set the percentage of spot versus on demand. It has a rolling update of my profile. So think about that profile had maybe a skew or the image. Well, I may want to update that. So when I update those, it will do a rolling update of the profile. I can specify the percentage of the scale set to change at any time. And if over a certain percent fails, then I can tell it to roll back. So it's a really great way to also maintain the capabilities. It does have auto image update. So it could be the marketplace, it could be a shared image. It will never do more than 20% at any time. And in this scenario, maybe I don't care about patching anymore. I won't patch. I'll just keep deploying a newer image that has the patches built into it. So it has the images updated with the new patches, automatically roll it out to my virtual machine scale set. So it gets the patches. It has instance repair. So it can auto heal. It might try a reboot. It might then try a reimage. It may just then delete and recreate the entire thing. It will never try and heal more than 5% at any one time, but it will go through and try and repair the health. And there's an application extension that health is not just defined based on the Azure health, but actually defined based on how healthy is the application running inside the instance. There is a scaling policy. It will try and keep the balance. So balance between, for example, AZs, balance between fault domains, and then it will delete the newest one and leave the oldest as best it can. So it will try and keep balance across the various fault domains or AZs. Then it will delete the VM with the highest instance ID, i.e. the one most recently created. So it will leave the oldest ones behind. When it is going to perform a deletion, it will send a termination notification. So this I can see within that instance meta data service endpoint. Services inside my VM can check that and it will get a notification. Hey, you're going to be deleted in 15 minutes. So maybe then I go and do some cleanup logic. I can configure that duration of what that termination notification actually is. If some of my VMs are a bit more special than others, there is instance protection. So imagine that VMSS flexible scenario. Maybe VMs I manually added in, I don't want to get scaled in. So I could set instance protection so they don't get scaled in if it has to do those scaling capabilities. Okay, so finally, compute fleet. This is for very, very large scale workloads. You could think about this being maybe massive compute jobs. Maybe it's a massive batch job. It can be up to 10,000 virtual machines. Now, again, this can use Spot. It can use standard virtual machines to help optimize my pricing. It can distribute not only over multiple AZs, but it can actually distribute across regions, which is a pretty cool capability. I think if I'm using the Spot, I can have between 3 and 15 different VM sizes. If it's standard, 15 is the max, but there's no minimum option that I need to do there. And what's really cool here is if I use Spot, I can set an action to say if you kick out the Spot because it gets evicted because someone else needs the capacity, we'll go and replace it with a pay-as-you-go instance. So it can maintain a certain size of my fleet based on the work it needs to do. So this is in preview at time of recording, but it's designed around the idea that I have some massive compute needs across AZs, maybe even across regions, but I still want to be able to centrally manage it. Well, that's what compute fleet does. That's not going to be something most of us will be using. And that was it. As always, I hope that was useful. And until the next video, take care.